Okay, the second thing, you had a second worksheet, very similar to the first worksheet. Okay, we have some Pythagorean equations to begin with. Then we go to some reference angles. Now, all these reference angles were in degrees, minutes, and seconds. They were degrees, minutes, seconds. So I made you work on that now. Any questions you have on the front side? Let's look at the front side first. Dealing with the degree, minutes, seconds. All solutions were provided for you. Once again, when the solutions are provided for you, you need to check your solutions. Once again, that's ownership by you into your educational process. Okay, that is ownership by you. Okay, so you need to complete the work. You need to check your answers to make sure you're working towards the correct answer. Okay, anything you need from the first page, the front side. Dealing with degrees, minutes, seconds. If we look at problem number 8 real quick, we have 319 degrees. $11 minutes, 13 seconds. If you have not done it, you should be doing this. If you've not done number 8, you should be doing it. Okay, 319 degrees. Which quadrant do you go into? Right, your terminal side. Roll in your terminal side. Yeah. Yes. Maybe you didn't get the worksheet that you had yesterday. Did you print off?
Since you didn't come in, yeah, I printed it off. But
For today?
Yeah.
Okay, quadrant. Which quadrant we in, Cole?
4.
Quadrant 4?
Yeah.
Okay, so we're going to rotate 319, 11, and 13 seconds. Once again, this is not an exact art. You don't have to worry about making this an exact art. Just need to make sure the picture gets correct. Okay, we're in quadrant number 4. Still doesn't mean you can't do the problem. Okay, terminal side, reference angle, theta reference, formed by the x-axis and the terminal side. The x-axis and the terminal side. So here's your reference angle. That is your reference angle. That's what we need to calculate. Once again, this is this rotation here. I need to find this right here. This amount of rotation, because angles are now rotations. Rotation's about the end point. So if I rotate to here, I go 319 degrees. If I rotate to here, how many degrees do I rotate if I go to here, Tyler Ramsar? 360. So all the way over here, it is 360. This is 319. Okay, so I'm looking at, okay, I'm going from here, it's 319. If I go to here, it's 360. What do I have to do with these two values to be able to find the value of our reference angle? Allison? Subtract them. So we have 360 minus the 319. 11 minutes, 13 seconds. Once again, if we have place values that are empty, throw in zeros there. Throw in your zeros. Now, once again, this turns into a problem like if we had 13 minus 4.93, and I have to subtract them. I throw in my zeros, my decimal point and zeros. I can't subtract, so I need to start borrowing. Okay, so I can't subtract here. I need to borrow from here. Well, there's nothing to borrow from, so I have to come over to here. So go ahead and go through the process now of borrowing. Borrow from your degree, make it into the minute. Then borrow from your minutes into your seconds. Once again, this is the practice that you need to do. I already know how to do it. After you check, after you're done, check your answer with somebody around you. Okay, we can't borrow any minutes into our seconds because there's no minutes there, so we have to go to the degrees, making it 359 degrees. Kylie, how many minutes is that? 60 minutes. Okay, now we can borrow a minute. So when you borrow a minute, Kylie, what happens to the minutes? This goes to 59 minutes, and then our seconds is what? 60 seconds. Now we can subtract down. Now we can subtract the 60 minus the 13, the 59 minus 11, and the 359 minus 19, or 319. So it should have 47 seconds, 48 minutes, and 40 degrees. Yeah, I'm going to put a name.
What is that, by the way?
What's what?
Oh, I don't know. You picked up that piece of paper.
Oh, that's zero.
Oh, okay. No,
You want to dabble on it again?
I could try. I would fail, but I could try.
All right, we go to the backside. We go to the backside. Questions you have about the backside? Yeah. Yeah. Hey. What I was going to do if nobody said anything. Problem 17. We have the sine squared of 120 plus the cosine squared of 120. Okay, now, as we talked about 2 days ago, what this means is we take the sine of 120 degrees and we square it, and the cosine of 120 degrees and we square it. So obviously what we should draw is an angle that's 120 degrees. So go ahead and draw your angle of 120 degrees. Once again, hopefully you're getting proficient at drawing these angles now and knowing which quadrant you're in. Once again, you should not be looking up here to see, well, okay, where's he drawing that, what quadrant that is in. Think for yourselves a little bit, 120 degrees. Should be in quadrant 2. Complete your triangle. Throw in your reference angle. Throw in your reference angle. Take, what's a reference angle? 60 degrees. So we have a 60 and a 30 here. 30, 60 right triangle. Okay, now we go to our 30, 60 right triangle. We have 3 values we have to put in there. A 1, a 2, and the square root of 3. Put in the 1, the 2, and the square root of 3. Once again, square root of 3 is approximately equal to 1.732, so it's not bigger than 2. The hypotenuse in both of our special right triangles has or involves the idea of 2 somehow. With the 45, it's a 1, 1 square root of 2. And the 30, 60, it's a 1, 2 square root of 3. The 2 goes, there's something that involves the 2 on the hypotenuse. So hopefully we are now recalling across from the 1 is a 30 is a 1, hypotenuse is a 2, and then the square root of 3 is across from the 60. Those are things you need to learn. Need to remember. Okay, check for any negative sign. Do I go left or do I go down on any of my sides? Do I go left or do I go down? Should be going left with my -1. So now we find these 2 ratios. What is the sine of 120 degrees? Now you got to refer back to what is the sine? How do we define the sine? Once again, your trigonometric Indian will help you out immensely. We have the sine, so throw in your ratio there. Then we have the cosine. Throw in your ratio in the next one. Jordan, what do you have for the sine? What do you have for the cosine? Got to say a negative. -1/2. Okay, now we are squaring all these quantities. So we're squaring every one of these. So if I square the square root of 3, just makes the radical go adios amigos. Goes bye-bye. But then I have to square my 2. So if I square the square root of 3 over 2, what do we come down to, Justin? 3 over 4. If I square -1/2, whenever you square a negative, it's going to turn positive. So I have negative times a -1, which is positive, and 2 times 2. Jack, what do we get for our second value? 1/4. So we have 3/4 plus 1/4. Adding fractions, this gives us 3 plus 1 over 4. 4 over 4, which is a value of 1. Tomorrow we will have a quiz. The review sheet looks very similar to the 2 worksheets we just did. hopefully your comfortability to the problems and the types of problems will be there for you. Yeah. I start you out with a couple radicals to simplify. All right, I've posted solutions already for it. There are solutions up here somewhere. Solutions are up here on the table. If you want to check solutions out here, you can check your Google Classroom. They are posted there also. And the rest of the time is yours. We've got about 20 minutes.